All right, number 12 and 5.7, they've given you a pretty messy integral right here, but they were kind enough to kind of give you a little suggestion here for what you ought to let u equal. So in this case, like I said, they've given you u already, and that u, that's your primary substitution, is going to get taken care of by this little piece right here. So this integral now is going to be the integral of, and our primary substitution is simply going to become the cosine of u. Okay, not too hard. But the tricky part here, as it always is the secondary substitution. We need to get x cubed plus 1 multiplied by dx represented in terms of u and du. So we pretty much always do that by starting with your u equation here and differentiating that. The derivative of u then is going to be a 4x cubed plus 4 with a dx at the end. Now, in an easier problem, that expression that you just got on the right might match the secondary substitution you were going for. But in most cases, like this one, you've got to do a little bit of manipulation to get it there. I don't want this 4 here, and I don't want that 4 here. That kind of tells me that I'm dividing the whole right side by 4, which means I better divide the left side by 4 as well. So I'm going to end up then with a 1/4 du, that's the better way to write that, is equal to, that's an x cubed plus 1 dx. And did you notice it? X cubed plus 1 dx is exactly what we needed for our secondary substitution. So, this is going to be really ugly, but everything that I'm circling here in green, x cubed plus 1 dx, can be replaced by a 1/4 du. So we'll put the du at the end here, and we'll move the 1/4 all the way out in front of the integral. So that really wasn't too terrible of a u substitution. The two questions you always want to ask yourself. Number one, did I replace all of the x's with u's, including the dx? And yeah, we did. Question number two, is the new integral easier to evaluate than the old one? And I would say definitely here. All right, so where are we, guys? The 1/4 kind of tags along right there. And the antiderivative of cosine of u, what function has a derivative of cosine? And that would be sine. So this is going to be 1/4 sine of u, and because it's an indefinite integral, we put a plus c right there. And all we have to do now is go back to our original u substitution, which was right here, and put that in there. So we're now going to end up with a 1/4 times the sine of x to the 4th plus 4x. That takes care of the u, and a plus c at the end, and that is our final answer to number 12. Now, if we wanted to check that, which is always a good idea, we could differentiate that. You'd start with a 1/4. The derivative of sine of any angle is cosine of the exact same angle. Gotcha. Times the derivative within. And the derivative of that angle would be a 4x cubed plus 4. So what would happen now? That 1/4 out in front would get distributed into that binomial at the end, and that's where we might end up with an x cubed plus 1 multiplied by the cosine of x to the 4th plus 4x, which should sound familiar because that's what the original integrand in this problem was exactly. So remember, guys, when you think you have your answer, which was right here, you can always check by taking the derivative of that answer, and what you end up with should match the original integrand perfectly. You just want to make sure that it's clear to whoever's got to grade this that that's not my final answer. This was it right here. Okay, so that's how we do number 12 and 5.7.